So it's second semester of AP Statistics, and your teacher keeps talking about this thing called z-scores. And like, you remember z-scores from first semester, but mostly you just remember thinking, I probably don't need to know what this is, right? You do. It turns out you do need to know what z-scores are. So you really want to ask what z-scores are, but
At this point, I'm too afraid to ask.
don't worry, I got you covered. For a really quick overview of z-scores and where they come from and what they mean, you can check out this video that I made, but here's the short version. A z-score describes the location of a data point in a distribution, and it basically gives us context about where the data point is located compared to other data points in the distribution. Z-scores are super helpful if you're comparing two different populations. So let's say you get an 84% on a math test. 84% is great. You know, that's a passing score, that's a good grade. Should you be excited about it? Sure. But if everyone else in the class got 90s, you can still be happy about the 84%, but like I wouldn't brag about it at the lunch table, if you know what I mean.
I have no idea what I'm doing, but I know I'm doing it really, really well.
Now, if everybody failed, then by all means, brag away about that 84%. That is much more impressive than if everyone else in the class got 90s. The same score, 84%, from two different populations can mean two very different things. Either you absolutely crushed it or not. So here's how you calculate a z-score. You take your value, you subtract the mean, and you divide by the standard deviation. The z-score tells you how far above or below your value is from the mean in the context of the standard deviation. A positive z-score means you're above the mean. Negative z-score means you're below the mean. The further the number is from 0, the further your data point is from the mean. So in the class where everybody failed, the mean was 62 and the standard deviation was 6.5. Your z-score is 3.4, which is basically saying that you scored 3.4 standard deviations above the mean, which is very good. In the other class, the mean was 93 and the standard deviation was 6.7. Your z-score was negative 1.3, which means you scored 1.3 standard deviations below the mean. So these are the types of questions you might see on the AP exam. You can tell it's about a z-score because it says z-score. Why don't you pause the video and read this question? So even if they didn't say the word z-score at the end, I can kind of tell this is going to be about z-scores because I've got two different populations. I've got the male grizzly bears that have their own mean and standard deviation, and I have the female grizzly bears that have their own mean and standard deviation. These two different groups that we're going to be comparing, perfect scenario for using z-scores. So what I like to do first is put all the information kind of written out in my two different populations. So let's do that now. I'm not sure if I'm getting any better at that transition, but I'm going to keep trying. The reason that I like writing everything out is it helps me see exactly what we're supposed to find. So for male grizzly bears, I have the mean, I have the standard deviation, and I have the weight of one particular grizzly bear. For females, I have the mean and standard deviation, but we're supposed to find the weight of the one female grizzly bear that has the same standardized score, or z-score, as the male grizzly bear. So I think the first thing we need to do is find that z-score for that particular male grizzly bear. So I'm going to take that grizzly bear's weight, I'm going to subtract the mean, and I'm going to divide by the standard deviation, and that gives me a z-score of 0.6. One nice thing about z-scores is you can kind of tell if you're on the right track just by using some common sense. It makes sense that the z-score is positive because this bear is heavier than the mean. And it also makes sense that the z-score is less than 1 because this bear isn't a full standard deviation above the mean. He's like a little bit more than half a standard deviation above. So it makes sense that the z-score would be 0.6. Okay, so now going over to the female, she has a z-score of 0.60 because it's asking about a female with the same standardized score. We don't know her weight. We're going to subtract the mean of all female grizzly bears and divide by the standard deviation of all female grizzly bears. Now the next thing I need to do is just solve this. We're back to algebra 1 here. So I'm going to multiply both sides by 40. So that would be 24. And then you can maybe just figure out what the answer is, or you can add 300 to both sides. Her weight would have to be 324. Which is B. And once again, logically that makes sense. The mean for females is 300. 324 would be not quite a full standard deviation above the mean, just like the male was not quite a full standard deviation above the mean. So that's z-scores. For a longer, more in-depth explanation, you can check out this video. I made that a long time ago. I know I look sunburned. I hadn't figured out lighting yet. Don't worry, I was okay. And if you have any questions that you're too afraid to ask, please drop them in the comments so I can make more of these videos. When I took statistics, I was in college and I was too afraid to ask pretty much every question. So I totally get it. I'd love to make more of these videos to help you out. So yeah, leave a comment and smash that subscribe button so you can be 100% confident that you'll ace the AP Statistics exam.